acquainted. Today I'm going to be talking about the fossils in our backyard, Southern California paleontology. I'm not going to go through the whole geologic natural history of California because we don't have enough time for that. That's a really cool thing because California has an amazing geologic paleontological history. We have fossils from all over the place. But today I'm really going to focus on my research, what I do and what I study here in California. So really quick, I thought there was going to be more kids here, so I'm going to go through this really quickly. What is a paleontologist? What is a paleontologist?
We study fossils.
Exactly! We study fossils as a paleontologist. What we do, actually, is not just look at fossils. We use fossils to study history of life on Earth. We look at when animals and life first started, where it first appeared millions and billions of years ago, and we study how life changed from the very beginning all the way up until today, pretty much. And so we go all over the place as paleontologists, and we study fossils. And fossils aren't just bones. Sometimes they're footprints. Sometimes they're poop. There's a lot of different ways we can study the history of life on Earth. So I am a paleontologist. I work at a museum called the Raymond M. Alf Museum of Paleontology, and we're located up in Claremont, California, just off the 210. If you want to come visit us, we're open 8 to 4, Monday through Friday. I am the collections manager there, and the Alf Museum is kind of a unique thing. We are the only accredited museum on a high school campus. Our museum was started by Dr. Ray Alf, who was a teacher at the Webb Schools, the high school campus that we're on. He used to take his students out looking for fossils, and that is what started the Alf Museum, his own personal passion for paleontology and finding fossils and taking students and teaching them about it. And because of him, he started a collection that eventually became the museum that I work at today. That's me in the museum, acting very professional.
Which one?
Which one?
Which one is there? With the big teeth or with the glasses?
The one with the glasses, because I'm the cute one.
Okay.
So a little bit about me. I'm a paleontologist and the collections manager. It's my job to take care of all the specimens in our collection. We have about 300,000 specimens in our collection, so I'm actually the first collections manager the museum has ever had, so I have quite the task ahead of me to get the collections in current standards of collection. That includes, getting things data-based, organizing them, getting them in nice little boxes so they don't break down over time. As a paleontologist, my real research interests really focus in on marine mammal paleontology, kind of the evolution of how things went from land to water, because it's super weird. Our ancestors originated in the oceans and they came on land, but then for some reason, some animals were like, you know what, I want to go back. So they adapted these really unique adaptations to go back into the water. I also studied Eocene paleoecology. So here in California, we have a great Eocene record from about 45 million years ago. That was my master's thesis, and I'll talk a little bit about that today. More recently, I started looking at research of science, communication, storytelling, and education. I want to learn how people learn and how they can best learn, specifically science, using paleontology. So that's a little bit what I do personally. I get to do a lot of fun stuff as a paleontologist. Paleontology isn't just some dude in a lab coat working in a lab. We get to do a lot of fun things as a paleontologist. Here you can see me with some of my other paleontology friends at the museum. I do a lot of social media talking about paleontology. I get to go to some really cool places. I got to go be part of the premiere of The Good Dinosaur. We got to set up an exhibit for that with Pixar. I wasn't at the Star Wars premiere because that was the day they made us move all of our fossils out of the theater, but I did get to say I saw a bunch of stormtroopers walk down the street, so that's why I had that there. I get to do a lot of fun traveling as a paleontologist as well. I get to go all over the place and sometimes some really cool places all over the world. Paleontology is an amazing, amazing field to get into. There's a lot you can do as a paleontologist. So one of the big questions I get as a paleontologist is, where can you find fossils? We're here in California, lots of cities, roads and stuff. It's not the typical place you see on TV and the documentaries to find fossils. A lot of people think you have to go to places like Mongolia. I'm kind of showing off now, I'm sorry. So this is me in Mongolia at the Flaming Cliffs. I went last summer to go help with an educational workshop there. This is one of the quintessential places to think about finding fossils. This is where we discovered Velociraptor, dinosaur eggs, Protoceratops. This is where the American Museum of Natural History went and did the famous expeditions. You can go to places like Peru. Here I am in Peru in the deserts looking for fossil whales. Again, these large, expansive deserts and the badlands where people really think you find fossils. Here I am, not that far from here, out in the Marble Mountains of California. And like I said, I thought we went to these places in Mongolia and Peru, but here in California, we have quite a great fossil history. We don't really need to go that far. We have fossils right here in our own backyard. These are fossils from the tar pits and the McKittrick tar seeps. These were fossils found right here in Southern California. We have quite a bit of fossils here. We have a really good, rich fossil history. We have fossils in Orange County alone that are as old as 175 million years old, all the way to the last ice age, about 100,000 years ago. I put 100,000 years because that's kind of where we put the division between paleo and archaeology. Don't ask me any archaeology questions because I don't know anything about archaeology.
Oh, interesting.
Yeah. So this is where we have some of the fossils we have here in Orange County. And I've kind of highlighted Orange County down there in the map. And there's just some fossil localities down there you can see. So right here, I've used a stratigraphic column from, I can't forget which one it was. So this kind of just shows what the history of California looks like. I know it looks like a lot of words, but if we kind of think of Southern California, LA and Orange County in particular, as like a large bucket, right? And at the very bottom, we have some of the first sediments from 175 million years ago. And then over time, those sediments just filled in and going up through time. So that's kind of what we can think of LA. It's like a big basin or a bucket. And through all those different time periods, we have almost a continuous sequence of natural history of rocks that tell the story of what life was like millions of years ago. Now, one question that I also get a lot of as a paleontologist are, where are the dinosaurs in California? Well, the answer is not in Orange County. That's because during the time of the dinosaurs, much of LA and Orange County was underwater. So we don't have very many dinosaurs. Most of the dinosaur fossils we have found here in Southern California or in LA, the coastal cities, were bloat-in floats. Some dinosaurs unfortunately died, or fortunately for me, died more inland than they fell in like a river and they start to decay and bloat. They floated off into the ocean, and then some other animals might have eaten them and tore them apart. And we just find bits and pieces of dinosaurs in our sediments here in Orange County and LA. But we do have a great fossil record of marine animals like ammonites, belemnites, Inoceramus, the giant clam. Some really, really cool stuff that are just as important as these dinosaurs. Honestly, if you ask me, dinosaurs are a little overrated, but that's because I'm a mammal paleontologist. Sorry. So as a paleontologist, we have all this great stuff to look at, but paleontologists don't get to study everything. We don't just study dinosaurs. We don't look at all of the fossils we find. A lot of times we specialize because, first of all, our brain can't take that much information, and second, we get exhausted trying to learn everything. So I really focus in on two areas here in California. One of my first research projects was in the middle-late Miocene, in the Pontic Formation, when Orange County was kind of a shallow sea. We had a lot of marine fossils at that time. And like I said earlier, I studied some of the Eocene, when California was kind of a rainforest. Here's a picture of what the Eocene might have looked like during California. This is a picture from the San Diego Natural History Museum. If any of you have not been, you should go check it out. It's a wonderful museum with a great Eocene exhibit, which is great for me because I love it. So during the Eocene, like I said, California was kind of a rainforest at the time. It took, the Eocene's about 56 to 33.9 million years in terms of time. And here in California, it was warmer and wetter. And actually, throughout the rest of the world, it was much wetter and warmer. In some places, it was about 10 degrees Celsius higher than modern global average temperatures. That's pretty hot for us today. And the Eocene is quite special because this is when the ancestors of today's animals first appeared. We have things appearing like rhinos, primates, camels, rodents, horses, and carnivorans, things like dogs, bears, cats. This is when they all first appeared, but of course they all look a little weird because these are their ancient ancestors. This is before they evolved and adapted to the animals we know today. And I love rhinos. Primates are cool. Actually, you know what? I do love all of them. Never mind. I take that So yeah, that's probably a little bit of what the Eocene looked like, and that's what I did my master's thesis on, was looking at the Eocene. I brought some of the fossils from that site here today for everyone to check out. And one of my favorite research topics is actually marine mammal evolution, like I said earlier, and that's why I like to focus in here on the Pontic Formation in the middle late Miocene. Like I said, during the Miocene, a lot of Orange County and LA was very different. We were underwater basically, right? So today we see the chaparral, we see deer and coyotes and stuff out there. That's not what it looked like during the Miocene. This is what it was more like. We had things like Megalodon, Carcharocles megalodon, the giant shark. We had tiny baleen whales. We had dolphins, all sorts of toothed whales. We had leatherback turtles. We had basking sharks is what it's called. So we had a really different environment back then. You know, we even had things like this. This is Titanataria orangensis. Titanataria orangensis is a tuskless walrus that existed during the late Miocene. This is a walrus that was described by my best friend Isaac Magallanes, and I got to be a co-author on it, and was just recently described last year. And this was found here in Orange County, actually. It was found down in the Lake Forest area, and it was a mostly complete walrus. But again, it's a tuskless walrus. It's super weird, because today we only have one walrus left, and it's it's got its characteristic tusks.
About how large was it?
About sea lion size, male sea lion size. Yeah. But today I want to talk about actually something very, very specific, and is my favorite research topic. I want to talk about Desmos Dillions, the hippo-shaped elephant-sized rhino relatives. Now, some of you are looking at this, and some people are like, Desmo, what now? Raise your hand if you've ever heard of what a Desmos Dillion is. All right, cool. Some people. Awesome. But for those of you who haven't, Desmos Dillions are what I like to call ocean hippos. But actually, this is a little misleading because they're not really a hippo. This is just kind of what they look like. But let's not just take this into our brain. Let's do a little imagination so I can get you guys involved in the story and kind of follow along and see what you guys got in your head. Oops, too fast. So everyone close your eyes. Everyone, I want you to picture that hippo, right, that I showed you earlier. Now take that hippo, even though we know that they live in Africa today, take that, pick it up, and put it into somewhere like in the ocean by Seattle. You know, that nice North Pacific forest. Now take that hippo, make its legs a little bit longer, take its face and stretch it out just a little bit, but blow it up to the size of an elephant. That is what a Desmos Dillion is. So everyone open your eyes. Is this kind of what you pictured? Kind of? Okay, it's hard because this has no meat on it. So that's me kind of being mean to you. But this is what a Desmos Dillion is. Like I said, they're ocean hippos, right? Or this is what I like to call them. They look very much like hippos, especially when we look at their skulls. This is the skull of a Paleo Paradox, a type of Desmos Dillion that was found in Orange County. And if you look at its skull and compare it to a hippo, you can kind of see the comparison, right? They look very similar. They actually had very similar lifestyles too. They were both aquatic marine grazers, or both aquatic grazers, one's marine, one's freshwater. But if you put some skin on it, right, it does look a little bit like what I said. A hippo-shaped, elephant-sized rhino relative. Ding. I'll get back to that later as to why I say rhino relative. So some facts about Desmos Dillions. They're extinct marine mammals. In fact, they're the only group of extinct marine mammals. All other marine mammals still have descendants around today, all other lineages, except for these weirdos. They were first described in 1888 by Nathaniel Marsh, the famous Marsh paleontologist. The first one was actually described here from California. And they actually have a really unique history because if you look at what Desmos Dillions are named after, they're named after their teeth, one of the most iconic and unique pieces of their physiology. Their name comes from bonded pillar, and if you look at their teeth, that's what they look like, bonded pillars. Desmos meaning bonded, Stylist meaning pillar. Sometimes I like to say they actually look like a bunch of sushi rolls all stuck together too. Usually I avoid that because it makes me hungry. So these are Desmos Dillion teeth. They're so common in the fossil record all throughout California. We have so many teeth of them through different collections from LA, San Diego, UC Berkeley. They're all over the place, and they're actually very common fossils in the fossil record. But where do you find them? Not just here in California. Desmos Dillions are found throughout the North Pacific. We find them in Mexico. We find them here, obviously in Southern California. We find them in Alaska. We find them in Japan. In fact, they're so popular in Japan, they're like the T-Rex of Japan. Everybody knows really what a Desmos Dillion is. When I got to go to Japan, and I'll talk about that a little bit later, they have like parks with like Desmos Dillion, like those little ones on springs that you can go back and forth on. They even have Japanese manga with Desmos Dillions in it, which I have not got a copy of yet, and I'm very sad about that when I think about it. So what were Desmos Dillions doing, or Desmos as I like to call them, because we're like on that nickname basis, I guess. They were semi-aquatic coastal herbivores, and they ate aquatic plants and algae either in estuarine, so like freshwater areas near oceans, or in seagrass beds. Here you can see some Desmos Dillions that was illustrated by my younger brother, kind of having a feast on some seagrass beds about 15 million years ago. And Desmos Dillions lived along our coast nearly 25 million years ago. So Desmos Dillions are grouped into about 3 different families. You have the behematopsids, which are the earliest Desmos Dillions that appeared about 33 million years ago in the Oligocene. Then from there, they kind of diverge into 2 different groups. You have the Desmos Stylist, the Desmos Stylist and the Paleo Paradox. You can find both of these all along the North Pacific coast living together, and they're really cool animals, honestly, if you ask me. I like to say they're kind of derpy and cute, too. Just look at its face. So why study Desmos Dillions? These are such weird animals. Why should anybody care? Well, for me, there's a lot of reasons to care about Desmos Dillions. As with any fossil, there's so many questions to ask, so many stories to tell, and for me, the untold stories of Desmos Dillions really gets a hold of my attention. So one of the first things that really gets a hold of me is we don't really know that much about them. There are many undescribed specimens throughout museums in the world, and there's actually few interested scientists who want to look at Desmos Dillions. There's kind of a joke that happened with some of the other researchers. There's like 4 or 5 of us here in the United States who actively look at Desmos Dillions. And a few years ago, they all went to Mexico to do a trip to look for Desmos Dillions and some other fossils. And I was a newbie then. I was like, I want to go. I want to be on the trip. And then one of my friends grabbed me by the shoulder and was like, no, you can't. Because if anything happens, you're all that's left. And I was like, oh, no pressure. So yeah, one of the reasons we don't know that much about Desmos Dillions is because there hasn't been that much research interest in them. That's not to say they're not interesting. It's just, people want to study what they study. And I'm one of the people who study Desmos Dillions. Number 2, we have so many unanswered questions. Like, first of all, why are their teeth so weird? That's a question we're trying to answer now. How big do they really get? So you remember that skull I showed you earlier? That one is about the size of a small elephant, right? And that's one of the largest Desmos Dillions we've found in the fossil record. But we don't know what their max size limit. Maybe they got bigger than elephants. So imagine something the size of an elephant stampeding down the beaches or like coming out of the water as you're in the beach. That's huge and also cool but scary. I would totally ride one. How many kinds of Desmos Dillions are there? I told you there's 3 main groups, and then there's different species within them, but there's a lot we still have to figure out, like variation within the different groups. Male versus female, sexual dimorphism in Desmos Dillions. Also, the fossil record is just incomplete. We may never find every single Desmos Dillion that ever existed. But we want to at least try to figure out how many kinds there are of that we can figure out. And also, how did they evolve? Desmos Dillions, the behematopsid, just sort of appear in the fossil record about 33 million years ago. And we're still trying to figure out who and what they're related to and why whatever their ancestors are decided, or not decided, but adapted from land to water. And another unique thing about Desmos Dillions is when you look at most other marine mammals, they're evolving flippers, they're becoming streamlined to, be in the water more actively. Desmos Dillions, while semi-aquatic, didn't really evolve in that way. They didn't adapt that way. What caused them to not need to adapt that way? Why did they adapt more of like a hippo lifestyle and a hippo body plan? And of course, what did they look like? This may seem like an odd question, but if you Google Desmos Dillion, you get a lot of weird ideas of what they look like when they had flesh on them. Because Desmos Sicilianus are not that well studied, and we have good skeletons, complete skeletons, and we have a lot of fossils of them. There's been a lot of different interpretations of what they look like in their life restorations, and this goes for a lot of animals. Life restoration is hard because you have to add flesh to something you don't know what it looked like. You're kind of adding a little bit of art to it. So you can see just the different variations of what Desmos Sicilianus might have looked like. Honestly, this one's my favorite. It looks like something from a video game. And number two, they are weird, and I just love weird. There's a lot of awesome fossil animals out there, but Desmos Sicilianus are just odd, and I want to learn more about something that odd that existed here in California like 25 million years ago. I really do love Desmos Sicilianus. It's kind of an obsession of mine. My Twitter handle is Paleo Paradox. I named it after Paleo Paradoxia, one of the groups of Desmos Sicilianus. I even got to go to Japan, like I said earlier. I went for my museum because I had to go bring this dinosaur home. This is a dinosaur at my museum. It's Dinosaur Joe. It's the youngest baby Parasaurolophus ever discovered, and it's at my museum. But while I was at this exhibit, right next door at the aquarium in Osaka, they had this exhibit, The Life and Times of Desmos Stylist, the Mysteries of Prehistoric Lives. And it was an entire exhibit dedicated to Desmos Dillions. So I had to go there. It was just coincidental that it was the same time I was in Japan. So I left that other exhibit while I was working to go check out this thing, and you can see I was pretty happy. They even had a complete Desmos Stylist skeleton there. I was very happy. There's a lot of selfies of me doing that. They even had this really cute game where you can paint your own Desmos Stylist. Mine was the one in the back. This ugly green one covered mine. It was the only photo I got. I don't remember if this is in here.
That's what they tasted like?
Probably. Oh, that was an inside joke, never mind. So also the reason I love Desmos Dillions is because Desmos Dillions were my first entry into paleontology, actually. I didn't always want to be a paleontologist. I actually went to my undergrad in biology with emphasis in pre-med. I was going to do medicine, but it just wasn't really for me. I prefer storytelling, I love education, and more learning about science than I do medicine, right? So when I first got into paleontology, one of the first things I learned about at the Cooper Center where I used to work at were Desmos Sicilianus. It was one of the first fossil that sparked my interest in paleontology and learning more about the ancient world. And I loved it so much that one of the first fossils I learned about was this thing. This is OCPC 22650, and this is just the lower jaw of a really old toothless Desmos Dillion. And it just so happened that this is the first specimen I ever did a publication on. This was the first specimen I ever did research and published on. It broke my teeth. Wait, no, that's not the expression. I cut my teeth as a paleontologist on this specimen. Broke my teeth, wow. So this is what OCPC 2265 looked like. And wait, I just told all of you that Desmos Sicilianus are known for their teeth, right? The sushi is all grouped together. But this is toothless. It has no teeth on it. If you look at the lower jaw, I'm looking at it from the top, you don't see any teeth in there, right? So why would a Desmos Dillion that is known for its teeth, the group known for its teeth, be toothless? Where are the teeth? Where are the sockets? If maybe it had teeth, but then it lost it, or they didn't get fossilized, you'd at least see the alveoli, or the sockets where the tooth would fit. But this doesn't seem to have that. Also, it's a really big Desmos Stylus. Why was it so big? Is this a new species? It's an actual question that paleontologists like to ask all the time when we find something we don't know about. So when I found this, and I was like, time to science. One of the first things we did with this specimen is we had to think about, what do we know? There's a lot of unanswered questions, but first thing we have to do is go, what do I know before I start making wild guesses? Well, we know it's a partial mandible, or jaw. It was found here in South Orange County. It's from the Pontic Formation, which is the Miocene formation here in California, or Southern California. And it's about 8.75 to 13.7 million years old. So there's lots of Desmos in California. So first thing I did was went to go check out other museums. I compared specimens. So here I am comparing this Desmos Stylist to a UCMP specimen that's at the University of California Museum of Paleontology up in Berkeley. I looked at specimens of Desmos Stylist from LA Museum, and here you can see one that has teeth, but it looks very similar to the bottom portion of this one, right? Definitely a Desmo. And then we started to look at other Desmos Dillions in different stages of life. Because once we're like, okay, we know this is a Desmo, it's just missing something. We want to look at maybe there's a reason that it's old or something. So we started to look at this one. This is a juvenile Desmos Stylist from Japan. And when we started to look at it, we started to realize that this young Desmos Stylist looks a lot different than an old Desmos Stylist. So eventually we started to put together the story that this was actually the mandible of a very old, elderly Desmos Stylist. And it was toothless, maybe grumpy, who knows? So why is this so important? Just this old toothless Desmos Dillion. Well, OCPC 2650 is the most elderly Desmos Stylist known in the fossil record so far, or that's been described. Someone may come along tomorrow and describe an even older one. Awesome, more data for me. Desmos Dillions lose or wear down their teeth through their life. So Desmos Dillions like to eat seagrasses. Seagrasses grow very low on the seabed, and there's a lot of sand, right? So if you're eating seagrasses and you're getting a lot of sand in your mouth, that's not going to be good for your teeth. You're going to wear those down to nubs pretty fast. But this Desmos Dillion was able to survive into old age after losing its teeth. So this was able to give us a much more complete story of Desmos Dillion life stages, or what we call ontogeny, how something changes from a baby to an adult, or in this case, a really old, grumpy Desmos Dillion. And by looking at all the different stages of Desmos Dillions from different collections or from different research papers, we were able to put together this really cool story. So basically what happens is when a Desmos Stylist is young, or a juvenile, they go through these different sets of teeth, and this allows them to eat seagrasses without losing their teeth early in life. So juveniles, they have their sets of teeth. Then as they become a subadult and adult, they go through these different sets of molars that get bigger over time to accommodate their change in size. And also, you can see that their mandibles get much larger, more robust, right? We're still trying to figure out what the reason is for getting much bigger, but there's definitely something changing from baby to an adult. So here you can see the different life stages. Desmos Stylist, we hypothesize in their very young juvenile ages, might have been eating seagrasses with their parents in like rivers or near estuaries, near bays in the ocean. Then as they get older to adult or subadult, they may have moved out into the seagrass beds where they were eating much more sandy plants in a sandy environment, which is why they may have gotten larger teeth to cope with eating all that sand or ingesting all that sand. Then at their final stage, at their elderly stage, when they lost all their teeth, we hypothesize that they may have been going off into deeper water and eating kelp. Kelp is a very soft algae. You know, there are some animals that eat kelp that you don't really need your teeth for. In fact, during the same time as Desmos Stylist, Hydrodamylus gigas, or Hydrodamylus was around here at the same time, and that is the toothless stellar sea cow. They were toothless, and they were eating kelp at the same time too. So another question that we had from this is, why do Desmos Dillions age like this? Well, they're kind of similar to elephant ontogeny. Elephants go through these stages of tooth eruption that they delay. Instead of getting all their adult teeth at once, they get adult teeth later through time. And this is because they eat grass. And grass is actually a very highly siliceous plant. It's got a lot of silica in its leaves, and that will wear down your teeth really fast too. Even elephants will lose their teeth at a very old age, and some elephants, once they lose their teeth, they can't eat anymore, unfortunately, and kind of die. That's what happens. So one thing that we got out of this, another question that we got out of this is, maybe this is a sign of, or evidence for the Desmos Dillion relatives. Who were they related to? But, you know, at the same time as I was working on this paper, and this is kind of how science goes, this paper came out that kind of said that, or that kind of hypothesized that Desmos Dillions might not actually be related to elephants. They may actually be more related to rhinos. And that's why I put that star in the very beginning, saying that they might be rhino relatives. This paper was saying that based on some of the other, you know, bones in Desmos Dillions, that they may be more related to rhinos and other perissodactyls, like horses and stuff like that. So there's just so much more left to learn about Desmos Dillions. You know, there's all those questions that I still have unanswered. And again, Desmos Dillions are found here in Southern California. You know, we go all over the world looking for these new stories of fossils, of, you know, dinosaurs and all these cool things. But Desmos Dillions are just one example of why we have an amazing story here in Southern California, why we don't need to go that far for paleontology to learn more interesting stories. Because there's things like Desmos Dillions here. There's things like Titanitaria that I showed you earlier. There are so many undescribed fossils here in Southern California that we have our own story that we still have to complete and tell. I'm going to leave you with one fun thing. In Japan, remember that exhibit I showed you? There's this really hilarious commercial with it. And I want to describe it more. I just want you to enjoy this experience.
デスモスチルスについてある仮説があります。デスモスチルスで私にラテルとでも。デスモスチルス分かってないのはあなたです。そういう意味じゃない。デスモスチルスが研究人物ブログ読んだんですか？目の上にいたらビザビザボザボザ生きてます。ラスイズのこの味です。こうだ。おめえらそこまで進化してないはずです。そう。言ってるのに信号の姿がデスモスチルスなんだ。ラピッツァ。だから実際はこうやって耳をゆっくりとです実はこうやって事実解説をしてくださいその実態をほとんど知らなかったデスモスチルスって何なんだデスモスチルスのいた地球海遊館で少しわかる
So that kind of plays into my thing because most of what they're talking about is what Desmos Stylist, they're kind of saying what Desmos Stylist look like, what they might have moved like, and those are all the same questions I'm asking as a paleontologist. And that's what the guy at the end says, like, they're all these people are talking about what Desmos Stylist move like, what they might have looked like, but the guy at the end just goes, what's a Desmos Stylist? So it's kind of a more talk, it goes back into what I'm trying to say and give the story about Southern California. We have people go out to look for fossils in all these great places, but we don't need to because we have these amazing stories in our own backyard that we still don't know that much about. So that's kind of what I was trying to pull together with that. It's a bit of a stretch, it's also a funny commercial. I still haven't quite figured out what the Italian is trying to say, except for pizza, so one day I'll figure that out. One quick promo that I want to do. As a paleontologist, I do a lot of fun things, but like I told you, part of my research now is going into education and outreach. And one of the things that I like to do is connect paleontology to things that we love in pop culture or video games or things like that. So I am part of a group called Cosplay for Science. And I just wanted to show that out there because we do a lot of stuff here in Southern California with paleontology. We do a lot of pop-up museums where we connect paleontology. Like we just had a Pokemon Natural History Museum. We showed how a lot of Pokemon are inspired by fossils or the animals in the real world. We're having a Star Wars Natural History Museum coming up in May out in Rancho Cucamonga. And a lot of what we do is talking about here stuff in California so that people can get a connection to things that they love and things that are part of their own history, part of their own culture here in California. So that's what I do as a paleontologist on the side. So I just wanted to kind of put that out there. Please follow us on Instagram. So thank you, everybody. If you want to learn more about my research, you can follow me at Paleo Paradox or Cosplay for Science. And if you would love to visit my museum or learn more about it, you can follow us on Twitter and Instagram on Alf Museum or Alf Paleo, or visit us online. So thank you, everybody.